Hi, in this video of import, I'm going to be discussing the assignment and rank of matrices, and we're only going to be doing a very few short questions, but these are the kind of questions that are asked in the exam, so please treat this video as very important. Okay, so the first question is to simply find the rank of this particular matrix. Recall that the rank of a matrix is going to be found by you calculating the minors, subsequent minors of starting from the highest order minor to the lowest order minor. The one which is non-zero, the order of that minor is equivalent to the rank. Okay, so if you perform the following row operations, I have listed them out here simply because this is something that you can just sort of check your answer with. If some other row operations actually lead you to the same result, that's fine too, but essentially you should be able to obtain the result that r4 is actually equivalent to minus of r3, and this would imply that the rank of a is has to be less than 4, and you consider any one of the minors moving from that point, and you'll see that one of the 3 cross 3 minors has to be non-zero, so the rank of this particular matrix has to be equivalent to 3. The reason I'm not solving this here is because the methodology to be followed is the exact same, and I think this will be a good exercise for you to do on your own. Okay. Again, you're supposed to do the exact same thing that we just did. You were supposed to calculate the rank of this particular matrix right here, and again, if you have some kind of a row operation business going on, if you have r3 equals to r3 minus r2, then you would have an upper triangular matrix right here, and if you consider this particular determinant, it is going to be minus 2 into 2 into 1, because the determinant of an upper triangular matrix is actually equal to the product of the elements in the principal diagonal. So I'm just going to write this out here. The only reason I put in this solution here is because I wanted to point this fact out once again, that the determinant of an upper triangular matrix is equal to the product of the entries in the diagonal. Okay, and this is a very important conclusion, which is why once you reduce it to an upper triangular form, things in life become a lot easier. You don't really have to calculate the determinant, you just have to calculate one particular product. Okay. Now again, you have to determine the rank for all values of the parameter k. I am going to solve this question once again, but I would suggest doing it either with me or pausing the video right here to solve it once on your own, because this is a concept that is once again very familiar to you, and this is actually a previous year question, so you can try it once to solve on your own. So you have if I'm going to solve it right here, so you have if you have to calculate the determinant of this, you would have 5 minus k into 1 minus k into 1 minus k minus 0 minus 2 into 2 into 1 minus k minus 0 plus 1 into 0 minus 1 minus k. Okay, and this would be equal to 5 minus k into 1 minus k whole square minus 4 into 1 minus k, okay, plus rather minus 1 minus k. Okay, so you have 5 minus k into 1 plus 2k, sorry, 1 minus 2k plus k square minus 4 plus 4k minus 1 plus k. Okay, so this would actually be equal to 5 minus k into 1 minus 2k plus k square minus 5 plus 5k. Okay, so you would actually have something like 5 minus k into 1 minus k square, which is what we had, minus 1 minus k, minus 5 into 1 minus k. Okay, so you can actually take 1 minus k out of this. Okay, so like I said, you have 5 minus k into 1 minus k square minus 5 into 1 minus k. So you can actually take 1 minus k out. Okay, and you have 5 minus k into 1 minus k minus 5 equal to, so if you know you have rank of A less than 3, then this would be equal to 0. So you would have something like 1 minus k into 5 minus k minus 5k plus k square minus 5 is equal to 0. Okay, so this 5 and this 5 can get cancelled out, and you have 1 minus k into k square minus 5k, k square minus 6k is equal to 0. Okay, so you have 1 minus k into k minus k into k minus 6, yeah, is equal to 0. Okay, so essentially if you have this is equal to 0, then you can calculate the values of k for which this is going to happen, and so on and so forth. You can proceed from there. So this is where I'm going to conclude this video, and I hope that the rank of a matrix as a concept is something that is very clear to you now. I would also suggest, if this is something that you are still not very comfortable with, to practice a few more questions. Hammond has quite a few questions on this. I have covered some of them here, but some of them have also been my own questions. So I would suggest going through the book also to look at the questions that they have. Particularly the rank of a matrix with unknowns is an important concept which has been asked multiple times in previous years. So make sure you familiarize yourself with it.